Hi everyone. This presentation is on the refrigerant cycle. You're going to want to pay really close attention to this. The refrigerant cycle in the automotive air conditioning system is the same as the refrigerant cycle in your air conditioning system at home. It's the same as the refrigerant cycle in your refrigerator. It's all refrigeration units work pretty much the same way. So pay close attention and do your best to get this. It's really important to understanding the repair of HVAC systems. So we're going to answer the questions. How do you know inside a refrigeration system if something should be hot or cold, if it's a liquid or a vapor, if it's at high or low pressure, and what does that mean? What does it tell you when you know those things? Let's start with one important principle. And that is the principle of heat. When an object is heated up, as an example, if we take a liquid and we apply heat to that liquid will get hot enough that eventually it will boil into a vapor. The reason it boils into a vapor is because it absorbs heat, and that heat causes the molecules to be more and more active. And in fact, the liquid has now reached a higher state now that it's a vapor. If we want to change the state of the liquid, or actually if we want to change the state of the vapor back to a liquid, we simply have to remove the heat. If we start removing the heat, eventually that vapor will condense back to a liquid. So liquid to a vapor, it's vaporizing or evaporating. That's vapor is part of that word. So evaporating is when the liquid evaporates up into a vapor. If you boiled water in a pan and you were able to catch all of the steam that came from the pan in a bubble, in a balloon above the pan, if you took that same amount of vapor and cooled it back down, took the heat out of it, that vapor would return to a liquid. It would condense. The molecules would get smaller and closer together, so it would condense back down to a liquid. Not surprisingly, a refrigeration system has an evaporator and a condenser in it. We're going to be working with this document, this Quadrants Shell. It has various places for you to fill in information as we go along. The shell is divided up into quadrants. You can see there's, red lines across horizontally and vertically, and that leaves 4 corners or 4 quads or quadrants. There are also halves on this chart, and they're depicted by these small half circles. So you have a right and a left half, and you have a upper and a lower half. So those are just some physical features of this document you're working with. You'll see how it all plays together as we go along. We're going to call this our air conditioning system and pressure system, air conditioning system, pressure and state of refrigerant chart. On this chart, the refrigerant is going to travel in a circle. And you can see the arrows, they depict the direction of that circle. We're going to start with some major components, the 4 major components of any air conditioning system. And that would be the compressor, the condenser, the flow control device, also known as a restriction device, and the evaporator. Textbooks show you a graphic that looks like this. And you can see those major components. Here's your compressor. It feeds into a condenser. The condenser ultimately feeds into a restriction device or a flow control device. And the flow control device feeds into the evaporator. The evaporator eventually feeds back into the compressor. So if you take the compressor and the condenser and the flow control device and the evaporator, you have the major components of an air conditioning system. Where are they located? Well, the compressor, that's usually hanging on the engine. It's run by a belt. Hybrid vehicles have electric compressors, so they don't use a belt, or electric vehicles have electric compressors. Some hybrids do. The condenser, that's in the front of the car. It's usually in front of the radiator. It looks a lot like the radiator. The flow control device, that can be in a few different positions, but in this case, we're talking about what's called a thermostatic expansion valve, and that thermostatic expansion valve, abbreviated TXV, is near the firewall. And if you go through the firewall, under the dash, you will find the evaporator. All of these parts are connected by tubing as you go through the system. Let's put those components in graphic form on our chart here. So we have the compressor at the top. We have the condenser, the flow control device at the bottom, and the evaporator on the right. So these are the components. We're going to work with words, but let's remember these graphics and what these components look like and where they're located. So we're going to start with the compressor. The compressor feeds the system with refrigerant. It's the thing that pushes it around. So we'll write in the compressor up here. And as the compressor forces the refrigerant around the system, well, it has a pressure side and a vacuum side, or a high pressure side and a low pressure side. So the high pressure side feeding is the outlet of the compressor feeding the system. When the refrigerant comes out of the compressor, it's in vapor form and it's being put under high pressure because the compressor is forcing it out. Next, we're going to go to the condenser. Remember, the compressor feeds high pressure vapor into the condenser. The condenser is at the front of the car. It has this fan that can draw air across the condenser, or it can get ram air when the vehicle is going fast enough. So we'll say the condenser removes heat. What it does is, by taking that air across the condenser, and because the hot refrigerant, the high pressure vapor refrigerant is inside the condenser, it removes heat. As it removes heat from the refrigerant, what happens? What happens when we remove heat from water vapor? Well, it condenses into a liquid. So we still have high pressure refrigerant after the condenser, but now it's in liquid form. Next, we're going to go from the condenser through the flow control device, or this restriction. This is a restriction. It's not a stop sign. It's just changing 4 lanes on the freeway into 1. So that causes a reduction in flow. So out of the condenser, we have this high pressure liquid. It meets this restriction, this reduction in flow, this reduction in lanes. And on the other side, it comes out as a liquid refrigerant still, but now it's a low pressure. This restriction device keeps the high pressure on one side coming out of the compressor, and it reduces the refrigerant to a low pressure on the other side. It's still a liquid in liquid form. From there, the flow control device feeds into the evaporator. Now, the evaporator works just the opposite of the condenser. When the refrigerant went into the condenser, it absorbed heat. It removed heat. It let its heat go into the air. Well, the evaporator absorbs heat. It takes the heat from inside the cabin and it takes that into the refrigerant. And because the refrigerant is now absorbing heat, what happened to the water when it absorbed heat? Well, it turned into a vapor. It evaporated. So the evaporator absorbs heat and the refrigerant changes back to a vapor form. So it's still in low pressure, but now we've changed it into a vapor by removing heat. That low pressure vapor then feeds back to the compressor. So that is our cycle of refrigerant as we go around. Now, let's combine the pressure, whether it's high or low, and the state, whether it's a vapor or a liquid. So start in this outlet of the compressor. Well, we have high pressure, vapor, refrigerant. So we're going to put that right there. Everything in this corner is high pressure vapor. Next, we'll move on to after the condenser, and now we have high pressure liquid. Combine those terms, we have a high pressure liquid in this bottom left corner of our chart. As it goes through the flow device, it becomes a low pressure liquid. We can fill that in there. And then once we move through the evaporator, it becomes a low pressure vapor. So back to the quadrants we were talking about. First, let's look at the system in halves. So dividing the system in halves, we can work with this chart right here. We have our compressor in the bottom left and our restriction device in the bottom right. Out of the restriction device is a low pressure side. From the restriction device all the way back to the compressor, the refrigerant is in low pressure. Because it's in low pressure, it's also in a lower state, the state being liquid. On the other side, coming out of the compressor is the high pressure side. And that high pressure side extends from the outlet of the compressor through the condenser all the way to the flow control device. So these are two dividing points when it comes to pressure. The compressor, low pressure to high pressure. The flow control device, high pressure to low pressure. There's another way to divide the system, and we can divide it in liquid and vapor sides. Remember the condenser, because it removes heat from the refrigerant, changes the refrigerant from a vapor to a liquid. So this would be a vapor side, this would be a liquid side. Go up to the evaporator, well, that liquid, because it's absorbing heat, changes into a vapor. So everything on the right-hand side is a liquid form. Everything on the left-hand side is a vapor form. So we have our pressure, high and low pressure dividing point, and our liquid and vapor dividing point. That's where we end up with the quadrants that we'll see on the next slide. Our high pressure vapor is after the compressor. High pressure liquid is after the condenser, ahead of the flow control device. Low pressure liquid after the flow control device, ahead of the evaporator. Low pressure vapor after the evaporator. Now let's discuss a few points. One is the compressor can only deal with vapor. Refrigerant compressors are not like compressors that you have at home where it compresses pressure in it, and it holds that pressure. The compressor is simply pushing the refrigerant around the system. The compressor itself does not build up pressure inside a cylinder like an engine does. It simply takes the refrigerant in one side and pushes it out the other. The only reason the pressure increases is because there's this restriction device halfway around the system. Another important thing to remember is the refrigerant, in order to absorb heat from the inside of the car, the refrigerant must be cold enough to absorb heat. So that's why we restrict the flow down and get it down to its lower liquid state, so it's in a position to receive the heat from inside the vehicle and cool the car. Here's some keys to remember about what we've studied so far. The system divides in 4 overlapping halves. You have a pressure halves, low and high, and you have state halves, liquid and vapor. Those overlapping halves create the quadrants. In order to identify the pressure and state of the refrigerant, combine the terms in each quadrant. For example, the lower left quadrant, actually I think it's the lower right quadrant, is a low pressure liquid. Knowing the pressure tells you the state and temperature. So if you take your air conditioning gauges and you connect it to your system and you see that one of the gauges reads a very high pressure, well, you know that's likely telling you that in that part of the system, the refrigerant is in vapor form and it has a high temperature. Things under high pressure also have high temperature. Here's 2 different types of air conditioning systems depicted in your book. This is the one we've been looking at, and it has the compressor feeding into the condenser, and then the condenser, out of the condenser, we have this high pressure vapor. Well, that high pressure, we have this high pressure liquid. That high pressure liquid goes into what's called a receiver dryer. This receiver dryer causes the moisture to come out of the refrigerant. Refrigerants, they don't like water. So if you have moisture in your refrigerant, things can freeze up. So this takes the moisture out of the refrigerant with what's called a desiccant bag. We'll talk more about that later, but that's what it is. It's a dryer. A desiccant bag is that little bag that you have when you buy your cell phone or a stereo for your car or something. There's a little bag in there. It's called desiccant, and it's made to suck up the moisture inside. Feeding out of the receiver dryer, we go into the flow control device. Now, we want this to be in liquid form, so the receiver dryer, one of the things it does is it tries to keep things in liquid form going all the way to the flow control device. So this system, this flow control device, is a thermostatic expansion valve, TXV. And the thermostatic expansion valve is near the evaporator. This is the other type of system. This is what's called an orifice tube system. In an orifice tube system, we have our compressor, and it's pushing around the system, and it goes into the condenser. Well, that's the same as this, compressor to condenser. Out of the condenser, we have this liquid going over to the restriction device. Well, the restriction device is what we call an orifice tube, and we'll talk about that when we look at all the individual components. The orifice tube restricts the refrigerant, causes it to go down to a low pressure liquid. That low pressure liquid feeds into the evaporator. where it is then turned into a low pressure vapor. The vapor, the low pressure vapor, feeds into something called an accumulator dryer. Well, remember I said the compressor can only deal with vapor. So if any liquid gets out of this evaporator, before it makes it back to the compressor, it has to circulate through the accumulator and release any liquid that's left there, liquid refrigerant, and it also has the dryer in it, the desiccant bag. So it leaves its moisture here and it leaves its liquid form here. So there's only vapor moving back to the compressor. Remember I talked about the pressure and temperature are related in the refrigeration system. If you see high pressure, you also see high temperature. So let's take a look at some of the temperatures. We're coming out of the compressor, this high pressure vapor going into the condenser. On the other side of the condenser, we still have the refrigerant at 175 degrees PSI, but it's down to 130 degrees Fahrenheit. Well, this temperature will keep refrigerant in liquid form. Liquid then feeds into the restriction device, and when it comes out of the restriction device, it's reduced down to about 30 PSI, and now that liquid is about 32 degrees Fahrenheit, the freezing point of water. So that very cold evaporator under your dash now gets to absorb the heat as hot air from the cabin is blown across it. And it still stays, it now returns to a vapor form, but it's still very cold. Now it's a cold vapor going back to the compressor. So when we look at pressures on a refrigeration system, the high side, we're looking at anywhere from 150 to maybe up to 300. And that's dependent on what we call the ambient temperature. If you have a car going to Vegas in 110 degrees, this high side might be 300. If you have a car driving around in the mountains on a 70-degree day, then this might be nearer the 175 psi on the high side. The low side, whether hot or cold weather, we want that low side to be right around 30 psi. If we get that low side down to 30 psi, we're going to get that refrigerant down to 32 degrees, and that refrigerant is going to be able to absorb the heat from inside the car. So the low side is fairly constant at 30 psi. The high side, it can vary quite a bit depending on ambient temperature. I hope this is all helpful. Again, your refrigerator works the same way. If you pull out your refrigerator and look at the back, you might see some coils on the back of the refrigerator. Well, that's your condenser. That's where it releases its heat. You can hear the compressor running inside your refrigerator. Underneath, somewhere inside the refrigerator, there's an evaporator. They take the air that's inside the refrigerator, they blow it across the evaporator, and it cools the air and keeps the inside of the refrigerator cold. And somewhere there's a flow control device after the compressor, before that evaporator. I should say after the condenser and before the evaporator. So that's how your refrigerator works at home. That's how your air conditioning works at your house. At your house, you may have a condenser sitting outside on a piece of cement out at the side of your house. And then inside where your heater is, they also have your evaporator. There's a compressor that you can hear running, pushing everything around. That compressor is usually outside with the condenser. So all of these components are in any type of refrigeration system. I hope you learned a lot from this. Be sure and get that chart filled out and turned in. Thanks very much.